When Filipinos talk about earthquake threats, the conversation usually centers on the West Valley Fault beneath Metro Manila, and the possibility of a magnitude 7.2 big one that could destroy hundreds of thousands of buildings. But there are two underwater monsters lurking just offshore that scientists fear even more, and most Filipinos have never heard of them. The Philippine Trench, which runs along the eastern side of Mindanao and up into Luzon, and the Manila Trench, which sits beneath Manila Bay, just 30 kilometers from the capital. Both of these subduction zones are capable of generating magnitude 8 to 9 earthquakes and massive tsunamis that could kill tens or even hundreds of thousands of people. Let's start with the basics. A trench is not just a crack in the ocean floor. It is a massive subduction zone where one tectonic plate is being forced underneath another, creating the deepest parts of the ocean and storing enormous amounts of energy over centuries. The Philippine Trench is one of the deepest trenches in the entire world, reaching a maximum depth of 10,540 meters, or about 34,580 feet in some sections. It stretches for roughly 1,120 kilometers along the eastern side of the Philippine archipelago, starting from the Bicol region in Luzon and running south past the eastern coasts of Samar, Leyte, and down along Mindanao. This trench is where the massive Philippine sea plate is pushing westward and diving beneath the Philippine mobile belt at a rate of about 10 centimeters per year. Over time, friction locks the plates together, stress builds up, and when the locked section finally slips, the result is a powerful earthquake. On October 10th, 2025, the world saw exactly what the Philippine Trench is capable of when a magnitude 7.4 earthquake struck offshore from Manay, Davao Oriental, triggering tsunami warnings across Mindanao and the Visayas. Just hours later, a second magnitude 6.9 quake hit the same area in what PHIVOLCS described as a doublet quake, meaning two significant earthquakes in rapid succession from the same fault zone. At least one person was killed, and thousands of residents were forced to evacuate coastal areas as tsunami alerts flashed across their phones. PHIVOLCS director Dr. Teresito Bacolcol explained that these events were caused by the movement of the Philippine Trench, and he warned that the trench is capable of producing earthquakes as strong as magnitude 8 or higher, which could also trigger tsunamis as high as 10 meters. But the October 2025 earthquakes were just a preview. Scientific modeling shows that the Philippine Trench has the potential to generate a magnitude 9.0 megaquake, an event that would release more than 30 times the energy of a magnitude 8 and nearly 1,000 times the energy of a magnitude 7. Researchers have modeled three hypothetical scenarios along the Philippine Trench: a magnitude 8.0, a magnitude 8.5, and a magnitude 9.0 rupture. In the worst-case magnitude 9.0 scenario, a massive section of the trench, stretching hundreds of kilometers, could slip all at once, displacing billions of tons of water and creating tsunami waves that would inundate the eastern coasts of Mindanao, Samar, Leyte, and parts of Palawan within minutes. Tens of thousands of lives could be lost in coastal communities that have little to no warning time and limited evacuation infrastructure. Now let's turn to the other monster, the Manila Trench. This subduction zone runs roughly north to south along the western side of Luzon, about 100 to 150 kilometers off the coast, beneath the South China Sea and very close to Metro Manila. The Manila Trench is where the Sonda Plate is being pushed eastward and diving beneath the Philippine archipelago, creating a locked megathrust fault similar to the ones that caused the 2004 Indian Ocean tsunami and the 2011 Japan tsunami. The trench has been locked for more than 500 years, silently storing tectonic stress, and when it finally ruptures, scientists predict it could produce a magnitude 9.0 to 9.35 earthquake, one of the strongest earthquakes in recorded history. Let that sink in for a moment. A magnitude 9.35 earthquake, stronger than the 9.1 to 9.3 Sumatra earthquake that killed 230,000 people in 2004. The total rupture length could reach 990 kilometers, and the maximum tsunami wave height could exceed 9 to 15 meters, with some models projecting waves as high as 20 meters in certain areas. For Metro Manila, which sits just 30 kilometers from the trench and has a population of more than 13 million people, this represents an almost unimaginable catastrophe. When the Manila Trench ruptures, Residents of coastal areas would have as little as 20 minutes before the first tsunami waves hit the shore. Inland areas could see water pushing several kilometers into low-lying districts, flooding homes, schools, hospitals, and critical infrastructure. Following an earthquake swarm in December 2024 along a section of the Manila Trench opposite Ilocos Sur, PHIVOLCS raised concerns about the possibility of a magnitude 8.4 earthquake in that area, with tsunami waves measuring up to 14.7 meters in height and reaching the coast of northern Luzon within a minimum of 2 minutes. 2 minutes. That is not enough time to organize an evacuation or even to fully understand what is happening. It is barely enough time to run. So now we come to the core question. Philippine Trench versus Manila Trench. Which one is the real monster? Let's break it down category by category. First, maximum earthquake magnitude. Both trenches are capable of producing magnitude 9 class megaquakes. The Philippine Trench has been modeled to produce a magnitude 9.0 event, while the Manila Trench has been projected to potentially reach magnitude 9.35, which would make it one of the strongest earthquakes in human history. Advantage: Manila Trench, by a terrifying margin. Second, tsunami height. The Philippine Trench could generate tsunamis as high as 10 meters along the eastern coasts of Mindanao and the Visayas. The Manila Trench, depending on the rupture scenario, could produce waves of 9 to 20 meters, with some sections of the coast potentially seeing even higher run-up as waves funnel into bays and river mouths. Advantage: Manila Trench, especially for areas directly facing the rupture zone. Third, warning time. For the Philippine Trench, coastal communities on the eastern side of Mindanao and Samar would have as little as 5 to 15 minutes from the time of the earthquake to the arrival of the first tsunami waves, depending on their distance from the epicenter. For the Manila Trench, Metro Manila and the western coast of Luzon would have approximately 20 minutes, though some northern areas like Ilocos could have as little as 2 minutes. This is a tie for terror. Both scenarios provide almost no meaningful evacuation time for near-field communities. Fourth, population at risk. The Philippine Trench threatens the eastern coasts of Mindanao, Samar, Leyte, and parts of Palawan, with millions of people living in vulnerable coastal barangays, many of them rural fishing communities with limited infrastructure. The Manila Trench threatens Metro Manila, the entire national capital region, and surrounding provinces, including Bataan, Pampanga, Bulacan, and Cavite, putting more than 13 million people in the direct impact zone, plus millions more in areas that would suffer from infrastructure collapse, fires, and economic disruption. Advantage: Manila Trench, because it sits directly beneath the country's political, economic, and cultural heart. Fifth, infrastructure vulnerability. Both trenches would cause catastrophic damage, but the Manila Trench poses a unique threat because it would not only generate a tsunami, but would also subject Metro Manila to extreme ground shaking, potentially collapsing up to 40% of buildings in the metropolitan area, according to some models. The Port of Manila, Ninoy Aquino International Airport, government offices, hospitals, power plants, water treatment facilities, and transportation networks would all be at risk of simultaneous failure. If the capital is crippled, the entire country's ability to respond to the disaster is compromised. The Philippine Trench, while devastating for Mindanao and the Visayas, would leave the national government and most of Luzon's infrastructure intact to coordinate relief efforts. Advantage: Manila Trench is more dangerous because of centralization. Sixth, historical activity. The Philippine Trench has a relatively well-documented history of producing large earthquakes, including the October 2025 magnitude 7.4 event and numerous other significant quakes in recent decades. The Manila Trench, on the other hand, has been ominously quiet. The most recent large-scale event originating from the Manila Trench was the 2006 Pingtung dual earthquakes, a pair of magnitude 7.0 quakes that produced a 40-centimeter tsunami, the largest tsunami experienced on the southwest Taiwan coast in recent memory. But a magnitude 9 class event from the Manila Trench has not occurred in recorded history, which means the trench has been locked and accumulating stress for centuries. This makes it unpredictable and, in some ways, more frightening. So, if we tally up the categories, the answer becomes clear. While both trenches are deadly, the Manila Trench is the real monster. Its potential to generate a magnitude 9.35 earthquake, its proximity to Metro Manila, the short warning time for tsunamis, and the fact that a rupture here would simultaneously destroy the nation's capital and command center make it the most catastrophic scenario the Philippines faces. As one disaster analyst put it bluntly, when the Manila Trench ruptures, 13 million people will have just 20 minutes before a 15 to 20 meter tsunami strikes the coast. This is the earthquake and tsunami threat most Filipinos don't know about, and it's bigger than the Marikina Valley Fault. But that does not mean the Philippine Trench should be underestimated. The October 2025 earthquake sequence, which included the magnitude 6.9 Cebu quake, the magnitude 7.4 and 6.9 Mindanao doublet, and dozens of magnitude 5+ aftershocks across the archipelago, has seismologists deeply concerned. PHIVOLCS described this activity as regional stress redistribution, meaning that multiple fault systems were shifting under immense pressure, a pattern that scientists worry could be building towards something much larger. The southern Philippine Trench off Mindanao's east coast remains one of the structures of greatest concern, with geological records showing it can unleash earthquakes exceeding magnitude 8.5 to 9.0 and generate tsunamis that could claim tens of thousands of lives within minutes. The uncomfortable truth is that the Philippines does not have to choose which trench to fear. Both pose existential threats, and both will eventually rupture. The question is not if, but when, and whether the country will be ready when that day comes. Japan, which experienced a magnitude 9.1 megaquake and tsunami in 2011, has spent decades building reinforced infrastructure, tsunami walls, early warning systems, and conducting public education programs, yet still suffered catastrophic losses with over 18,000 people killed. The Philippines has made progress through collaborations with JICA and PHIVOLCS, expanding seismic monitoring networks and improving coastal warning systems, but challenges remain. Many rural communities along the Philippine Trench lack reinforced evacuation centers and clear tsunami routes, and public awareness in Metro Manila about the Manila Trench threat is shockingly low. So what can you do if you live near either of these trenches? First, know your risk. Check whether you are in a coastal area that could be hit by a tsunami within minutes of a major offshore quake. For Philippine Trench communities in Mindanao and Samar, and for Manila Trench communities along the western coast of Luzon, this means understanding your elevation and distance from the shore. Second, learn the natural warning signs. Strong earthquake shaking that lasts more than 30 seconds, especially near the coast, is an automatic evacuation signal. Do not wait for official warnings. Third, identify and practice your evacuation routes with your family, knowing exactly where the nearest high ground or vertical evacuation building is, and how long it takes to get there on foot. Fourth, prepare an emergency kit with water, food, flashlight, battery-operated radio, first aid supplies, and copies of important documents, and keep it accessible so you can grab it within seconds. And fifth, participate in local tsunami drills and educate your community, because survival in a near-field tsunami scenario depends on immediate, informed action by individuals, not just on government warnings that may arrive too late. The Philippine Trench and the Manila Trench are not distant, abstract threats. They are real, active geological structures that will eventually produce catastrophic earthquakes and tsunamis. The difference between survival and tragedy will be measured in minutes. And in those critical minutes, the only thing that matters is whether you and your community understand the danger and know what to do. If this video helped you understand these two monsters and why the Manila Trench is the most dangerous structure in the Philippines, like, subscribe and share it with your family, neighbors, and local officials so more Filipinos can prepare. And watch the other videos on this channel that break down the Negros Trench, the West Valley Fault, and the other hidden dangers threatening our islands. Because understanding where the threats come from is the first step in protecting the people you love.